Okay. All right. So notes officially started showing that calendar. What we were doing is just looking at the greatest common factor of this. And first of all, they break it down numerically. Looking at the numbers, what is the GCF? Well, between 12, 8, and 6, when you break it down into a prime factorization, 2 is the number that they all have in common. That's what I'm going to be able to undistribute. And then for the x's, the first term's x to the fifth, second, fourth, and third, they all at least have 3x's or x to the third in common. So bottom line, the GCF of 12x to the fifth, 8x to the fourth, minus 6x to the third is a 2x cubed. And then eventually what you're going to be able to do is undistribute that and write this in what's called factored form. So that is division, dividing it out and going backwards. And then to figure out what's left over, you take each one of these terms and divide it by that to see what's left over. And then good FOILers are, say it, good distributors are good factors. When you're done, you just recheck. If I throw that back in, is that correct? Meaning, does it mirror the, if I were to distribute this? So 2 times 6 is 12, x cubed times x squared is x to the fifth. That's why that's what's left over in the first term. This is 3x, and then this is not 0, but 1, okay? This divided by that is actually 1, and that's another common error. People just write nothing there. They write error, and they even write 0, but they don't write 1, and you're wrong. All right, because I need the 1 there. Think about distribution. Throw that back in, and then it exists. All right, so that is the actual factorization of that. Okay? All right, and then here's just another one. This is arbitrary, and you don't have to write this one down, especially if you're, yeah, I understand all of this, Mr. Samuelus. It's arbitrary if you do take a negative or not. That's a question. Usually you do take out the negative, so then you could have a leading positive coefficient there. Yeah, that's exactly what I wanted to say. So then, are we going to do this way and break down every term like this? No, this is our thought. This is our thoughts. We look at 12, 18, and 27. And at least 3 goes into all of them. But does anything else go into it? You have to think about it. Actually, if you pulled out a 3 and then you look at your answer, make sure it's all the way done. And maybe there's another factor. But we are not doing this. Is inefficient to take each question and break them down like this. This is your thought process, okay, in order to get that out. So I just wanted to make sure you understood that as we move forward. So, kind of an explanation in the book. So, we're going to start with Charles. Look at that number 2A. Take a breath. And then tell me, Charles, what is the GCF of 5 or number 2A here? 1. And then what about variables? Okay, 1 what? All right, so what could I pull out of this that at least each one of these have? X to the first power. And very well said there. Now, this is all they're asking. So when they, oh no, it does say factor out. My bad, dogs. All right, rough. Okay, now what's left over, Charles, when I take that out? What's left? What does each term become when I divide out an X?
X to the second power. So we got 5x.
All right, and then the last one?
22.
And then it's just minus 20. Some people sometimes forget about that last one and then say 22x again. All right, very Mickey Mouse stuff, I think. Not too bad. Let's get another student. Hopefully I can get you real fast. Hey, look at that, Charles. Calculator loves you, man. Hey, look at the next one now. Hey, I will tell you this. It is a good idea, but it's not mandatory. But it is a good idea when the leading coefficient's negative is to pull out the negative. So I'll throw that out there. Now it gets a little bit tougher. 16, 28, and 20. What do you think the greatest common factor is numerically? 2 could work, but you better check, does 4 work? 4 goes into all of those, right? So if you pulled out a 2 and then wrote your final answer, you would have seen that they're all even still on the inside. Then you'd have to do some more. Okay, got it? And then what about the variable? A little bit bigger. So you're missing something here. You got to go y to the 6th, y to the 4th, and y to the 3rd. What do they at least all have? They have more than just y to the 1st. Y to the 3rd. All right, so that's what we need to recognize for that. And then what's left over?
4y to the 3rd power.
Good. Knowing your exponents, knowing a power times a power, or a y times a y, you add the exponents. So that's why that has to be y to the 3rd. Go ahead.
That's negative 7y.
And then what else?
And then negative 5.
Ooh, it's positive, right? Because you had a negative pulled out, right? And then it's 5. So be careful on that as well, keeping track of your um, signs. I couldn't think of the word there. Okay, good. All right, so hopefully you remember this. Now, when this gets into like review, we'll probably have like a 2-1 to 2-6 review. Sometimes that's factorable, and then you have to factor completely. That's definitely going to happen in the future. But for today, it's not. It's just all GCF and 2-4, and then 2-5 is all another type of factoring with trinomials. Okay, I don't know if I want to do this too much because I think the point is established here. So I'll maybe hit these two with student number. What if it's 18 again? Oh, what did we have in here? I forgot. Was it 25? Right? 24, 23. Nice. All right. Madison. Okay. Sorry if I'm cheating on my, I don't know all your names yet, of course. Look at number 8. It's not a polynomial, but they're just asking what's the GCF between these two terms? Between 8 and 28, what do they have in common? 4, and it's 8 to the 2nd. And then that, when they're worded like this, you're done. And that's it. All right. And that's pretty easy. Let's see if there's something better than 10 here. Yeah, let's go to 11. Although numerically it's not the best. Hint, hint, hint. Sorry, it takes so long to get those students. 10. I know who that is. Nice. Cameron. Okay, 14 and the 15 thing here. Let's skip to 11. 1x to the 6th, y to the 8th. Okay, good. And hopefully we are getting that. And then if it was like a plus in between these, then we could divide it out and then see what's going on from there. So I think the point is established, and I don't think we have to hit all of these as far as what's going on here. So far, so good. Hopefully you're not all stressed out about this calculator student picking thing, right, Jack? The Jack attack, you all ready? Okay, now it's back to the questions that we had earlier. Let's just do 13 and 16. I don't think I have to even slide over to that last one. The points made. Tell, what do you think you want to do? What would be a good idea? I've mentioned this. Negative is a good idea. Not cutting you off. I'm hammering what you just said there. Then what else? Keep going.
All right, so it's negative 3x to the 2nd.
And then what's left over? Doing your division correct.
X to the 2nd.
Correct.
Minus
Correct.
4x.
Okay, good. And you don't have to write first. First student of the day said x to the 1st. You can or you don't have to.
And then
Plus 7. And then this picking of students thing, we should be picking this up. And then as I keep picking students, it does tell me if we're on task or not with what's going on. 9, 10, 11, 12. Victoria, is that right? Okay, then just go ahead and do this one. Well, I probably should. No, let's do that one. Oh, big numbers. I just switched gears on you. All right, sorry for those that are racing. I was like furiously erasing because I made a change. Okay, so I'll give you a second to think. All right, Victoria, what is the numerical GCF? Made the numbers bigger and it's no calculator. But think about money. Think about like quarters and stuff. But that's not correct. But what goes into 100 and 150? 15? Actually, I don't think 15 goes into 100. All right. Doesn't 25 go into all of these because of money, right? But it's still, that's not the greatest common factor. I gave you a hint. 50. That's why I had to listen to what you said there at first. I thought you said 50. It's definitely 50. And then what about the variables? What can you pull out of each one? And then you will find that in GCFs, probably the variables are easy. Sometimes the numbers are harder because you have to know some, you got to be really numerate with that. All right, tell me what's left over when you do this. Nice. Yep, that's it. Right. Good. Good thoughts. All right. So that one, I'm glad I moved to that one. You got bigger numbers plus, a lot of stuff going on with the variables. Then, of course, we got this, and I think this was a question that was on your pre-test, which I did kind of want to discuss at some point when we have time. The area of the rectangles are given. Use factoring to find the expression for the missing dimensions. Okay, so I'm pretty sure there was one like this. Maybe not a GCF. It might have been a different kind of factoring question. Okay, so again, these are just silly little math questions to just make you think factoring wise. So if this represents the area, this long drawn out expression, then what possibly could be the dimensions, length, and width? It's a factoring question. What's this times this that equals the answer in the middle? It's really all it is, and that's what happened on that little pre-test that we did. Pretty sure, if I remember correctly. Do we have 25 students in here, Brandon? Right? Yeah. Okay, so what? And I don't care where you put what. We're going to put one dimension here and one dimension here. I think this one will put the GCF. Okay, so what is the GCF of what you see there? 5AB. 5AB. I agree. So if that's 5AB, then what would this dimension have to be? And that comes from dividing it out so that, you have this in factored form in a way. So what do you end up with? 2AB squared. 2AB squared. Plus 3B. 3B. And plus 4A. 4A. And then none of these are like terms because they couldn't be. They weren't like terms in the beginning. You pull out a GCF, they're still not going to be like terms. Just a random thought there. Okay, so hopefully we're good on GCF factoring. The way we're going to start this off is break these down like each type of factoring one at a time. Then you're going to get a worksheet and you got to know what to do in all cases and be able to make some decisions. Always, though, you look for a GCF first no matter what question you're dealing with. All right, like I said before, back up to this, not to over explain, or I'll just go to this. Many times in the future, you take a GCF out, and then the remaining set of parentheses is factorable as well. Do you remember that from last year? Of course that happened, and that's your job to make sure. Sometimes that can factor in two different ways. You factor again, and then there's one more part that's factorable through special cases. So that's what you need to be aware of with that in the future. And I do have them together. Okay, now it's 2-5. And the reason we're putting these two together, I'm glad. I think you guys are more prepared than last year's group, meaning I think last year's group didn't see as much factoring as you. We changed our curriculum last year, so so you guys are a little bit more trained than last year's. But also, this isn't too bad. But you really got to think about this as a very specific case, and then you got to put a file in your brain. And that's what we have to do in math. We really got to organize our stuff about what kind of question I have. So that when I get a big worksheet of a whole bunch of different factoring questions, I access the right file when a trinomial looks exactly like this. Because when it does, boom, you're going to get the answer right away. There's no long, convoluted set of steps to factor this. So it's a trinomial in what's called quadratic form. X squared plus number times x plus number. That's what B and C will always represent. All right, this next person has to answer two questions. It really comes down to knowing how to be numerate on questions like this. I'll actually show the two. No, I'll show one at a time. So who's 18, 9, 13, 7? Is that Charles again? Charles. Calculator loves you. What two numbers multiply together to equal 15 and add to equal 8? So what two numbers multiply to be 15 and add to be 8? What would those two numbers be? So two different numbers that multiply to 15, then those same two numbers add to be 8. 5 and 3. Okay, now let's move on. Next box. What two numbers multiply together to be 15, but add to be negative 16? Interesting.
-1 and -15.
There you go. Now here's our rules for, and I think this is what happens when we get into factoring with these things. People are not numerate. They're innumerate. You know what illiterate means? You're bad at what? What are you bad at if you're illiterate? Just in general, what subject in this school? English. Innumeracy means you don't understand your number rules. You don't understand that a negative times a negative equals a positive, and that's why these numbers are what happens with what he just said there. A negative times a positive is a negative, and so on and so on and so forth. Always with factoring, this is what comes up as the problem. 14, is that right?
Yes.
Cool, nice. Luke, two more. Were you named after Luke Skywalker? Anyway. What two numbers multiply to negative 15, but then add to be negative 2? Interesting now. So if you have a multiplication that's negative 15, we should know that we have a negative and a positive.
It'd be -5 and 3.
There you go. It's the same two numbers that Charles said, but now we got a different combination of who's negative and who's positive. And then the last one, and I like how they did this, they're keeping with 15, either positive or negative, and all the different possibilities that you could have. So now reading that one, multiplies a negative 15, adds negative 14. Yes, yeah, two in a row.
1 and -15.
There you go. So it's negative 15 and 1. And I love this because it keeps 15 as the number, but all the different things that could happen in this analysis. And that's what really comes down to, and don't write any of this down, but good foilers are? What? What is this first hour? No one talks. I'll do it one more time. Good foilers are? Good factorers. This book is awesome. Don't write any of this. They start this factoring section with a foil because they understand that the process of FOIL is reversed to factor. And they show this step. Here's x plus 2 times x plus 3. Here's the foiling of it. And then here's the answer. And then sure enough, I'm not going to continue with what they have here because this is what they break down. Look at this number right here. That is the product of 2 times 3. 2, 3, right? So this is what we will call the M number for our analysis for factoring. And then look at 2 plus 3. Okay, and then I'll highlight these in yellow, and I'll highlight this in green. 2 plus 3 equals the middle term. So I will call that the A term. And maybe you do want to write this part because I'm not going to show the rest. They keep expressing this idea. For us to factor this x squared plus 5x plus 6, it's an MA analysis. The M number is always the last number, the constant. The A number is always the middle term. This only works, this analysis, when 1 is the leading coefficient on x squared. When it's not, it gets a little bit more complicated. Okay? All right, so that's the idea, and hopefully in honors you remember this and can continue and be efficient on this. So they do say this, but it's a little bit crazy how they write it. And I don't want you to write any of that. I want you to understand that. Okay, so here's how you break this down. Whoa, 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 whoa. Anyone know that song? Can't touch this? Nobody? Nice, thank you. So if you're 14, you're 16, right, Larissa? Correct? All right. So let's take this first one. Write the factored form for each trinomial. And by the way, you're going to get sick of me saying it. I couldn't care less. Good foilers or good factors also mean something else. When we're done with our answer, we're going to check it mentally. Okay, but here's what we've got out of this, Larissa. To factor this is M and this is A. And you want to think about what two numbers multiply to 36, But then those same two numbers add to 13. And then this all comes down to your times tables that my Lexi Samuel's 11-year-old did like 4 years ago, doing all the 1 through 12 times tables times 1 through 12. So Larissa, do you have the numbers yet? Or let's think about what multiplies to be 36. What are our possibilities that multiply to equal 36? 4 and 9. Is that the one? Do 4 and 9 add to be 13? Then here's what's guaranteed to happen. First of all, why do we have x times x here? Good FOILers are good factors. What's x times x, everybody? X squared. And then we put 4 and 9 here. At least what we're good for, and they're both positive because we have pluses all the way through. For last in FOIL, what's 4 times 9, everybody? 36. So right now, I do have this, and I do have this if I were to multiply these. I'm good so far. But am I good for the middle term, which I'll color maybe in green? No, I won't, I guess. Now I will. 9x and 4x. Is 9x plus 4x equal to 13? This is why this works. So you're not going to actually multiply, but you're smart if you really quickly check. Does this FOIL to be that answer? Okay, then I factored correctly. So see how it's about your times tables, and that's what's going to be important for this. Okay, same one. Maybe you could just tell me the answer and I can break it down. Student number 24, Wade. What multiplies to be 28? Same two numbers add to be 11. And by the way, as Wade thinks about this, what if there is no combination of numbers that satisfy that? Then it's unfactorable. Not everything has to be factorable. Got it? Wade, you got something?
It's 7 and 4.
7 and 4. So what does that mean the final answer is for factoring?
It's x plus 4
Ooh.
over 7 and
Oh, too late. So what do you have to put in the second one?
plus 4.
Oh, another x plus 4 or what?
Well, I know I just switched it.
Is it okay that we write x plus 4 first and x plus 7 second? I was messing with Wade. That's actually okay. I saw someone shaking their head no. It's commutative. Multiplication's commutative. It doesn't matter which one you write first. Hey, put that mask on. We're in COVID right now. All right. Okay, so let's get some different combinations, and then it's really, this is it. So I'll just see if we got some students. You know what? I'm only going to do one of each section now because each section has different components going on. 17, but the same concept. 9, 10, 11, 12, 13. What did I get?
I think it's the last person.
14, 15, 16. So Nicole? Yes. Okay. I hate that second row is 5 because it throws off my, we get an odd in there. Okay, what do you got for multiplies of 15 and adds to -8? And it will work. I forgot to check the last one, but it definitely checks out. So then what do I put in these parentheses? You see why this is going to be a quick section. All right, and then the GCF shouldn't be really that bad. Again, x squared, positive 15. So I got the first and the last term. Middle term, negative 5x and negative 3x is negative 8x. We're all good. But don't actually FOIL. I have people that go in circles in these questions. And then they write what the question was, meaning they get this answer, then they FOIL, and then they write that as the final answer, which was the question. You're just checking is all you're doing. Let's go to the next one. And again, this is all about different combinations of numbers on the small side. Student number 20. So what were you, 7, 18, 19, 20? There we go. Good. Jacqueline, good. You're new. I haven't had you today here. So just waiting for you. One more time. Okay, negative x. Wait. Negative 7. Yeah, okay. That's why I was confused. Correct. So then what would the answer be? Just so we know how to write the factored form. And it works. So she said -7 and +2. And then I asked, okay, so then what's the final answer in factored form? X minus 7, x plus 2. Or you could write x plus 2 first. Again, I think you get the point. X squared, -7 times 2 is -14. Double check yourself. That's also the annoying comment. Good FOILers are good factors. When you do these fast methods, then take a second to check your answer. You don't have to write it, but mentally check it. All right, and then these last two, I guess I will do the last two because we've added a component here. This is where the variables start getting a little bit bigger. I'm sure you've seen this last year, or at least there's more of them. Okay, student number 14. Let's get our two students. So we got 14 first, and then 9 second. Nice. 9 is Evan, 10, 11, 12, 9, 10, 11, 12, 13, 14. Luke, you go again. All right, so Luke, you're first. Here's what you do on this, Luke, and I want to help you out here and everyone else. And I'm sure you've seen this last year, but if not, yeah, when we get to that factoring worksheet, we're going to have questions where there's multiple variables. Of course, Luke, x times x is x squared. So that's why this is still going to be true. Got it? But then in your second term, you're going to have a y and a y here because y times y is y squared. So that'll accomplish the y squared at the end. Once you understand that, then it's still a simple MA analysis. What are the numbers here? And all you have to focus on is the 32 and the 12. Does that make sense? Okay, so what multiplies to 32 and what adds to 12? Yeah, what two numbers multiply to 32, same two numbers add to be 12?
It should be 8 and 4.
There you go. And it's funny that, it's about that. I think using the calculator too much. We really need to be looking at our times tables and really thinking about that. I think in your Porter planner, there's a times table 1 through 12, 1 through 12. It used to be anyway. Anyone have a Porter planner? Do we have Porter planners anymore? What? What is going on? I'll have to ask about that. We may not have Porter planners. Bummer. Okay, and then the last one, Evan, you'll end the day. I think that's it. Do I have any crazy questions? No. I do have one more thing to show you though, and you don't necessarily have to write it down. But okay, who did I say? Evan in the back there. Evan, same thing. Don't freak out too much. It is x, but with that y squared, the last terms have a y and a y attached to them, and that's how you end up getting y squared. So all you have to really worry about is what multiplies to 21 adds to negative 10. What are the two numbers? And you'll see why we're really fast if we are really numerate, if we really know our times tables. Then these are gonna your homework's gonna take no time whatsoever. It's amazing with the factoring section when I give you a future worksheet, how many people are done in 10 minutes and how many people have half the worksheet to take home. All right, it's just the balance. All right, and we're in honors, and it's up to you to get yourself picked up and caught up with the rest of us, and that's really the truth. And then just real quick, so you understand that this is true. Sure, that's x squared. I always like hitting those last to make sure I accomplish last. Negative 7y times negative 3y is positive 21y squared, so I know I'm good so far. And then this is how we get that xy middle term. Negative 3xy and negative 7xy do add up to be negative 10xy. Good FOILers, good factors. You check at the end in all cases. And then I'll wait for other comments that I make where students that don't check the FOIL, they write answers that are absolutely ridiculous, that make no sense whatsoever compared to the question that we have. And that's when it gets a little bit more complicated. Don't write this down, but it's just hammering down the point. And I love number 39 in the homework because it makes a comparison with this again. Like, look, I have 14 three times as my M number. But because of how multiplication works with positives and negatives, different answers result in making sure you understand those concepts. So of course at 7 and 2, I think we had this at the beginning. So that one's x plus 2, x plus 7. But when we have a negative middle term, that means two negatives multiply to be a positive. Now it's x minus 2, x minus 7. When you have an m that's negative and an a that is either positive or negative, then I have a positive and a negative. In this case, the negative is larger. So it's x minus 2x, or x minus 7x plus 2. Number 39, hammers that point, and I think it's a real great teaching point within that question. All right, we're